Yeah, largest value in each level. Given a binary tree, find the largest value in each level. So okay, so the first level, it's just only one element, only the root element, so that will be the largest one. Now in the next element we have 2 and 3, and we have a 2, okay, and then we have a 3, and 3 is greater than 2, so 3 is our next largest element, so 1 3 will be our answer here. Now here 4, okay, 4 will be the first one. Now here 9 and 2, so 9 and 2 means like 9 is the largest, 9 is greater than 2, okay. Now here 3 5 7, 3 is less than 5 and 5 is less than 7, so 4 9 7 must be the answer. So okay, here there is only positive values, okay. The number of nodes 1 less than or equal to, okay, this didn't mean like we are having only positive value, okay. So here like it's pretty straightforward. We can just apply level order traversal by maintaining a maximum value for each other. So let's take this example and we can just work it out how this will work. So we are having 4 9 2, then we have 3 5 and what was there, 3 5 and 7, okay, 3 5 and 7. So our answer is 4 9 and 7. So what is level order traversal? So level order traversal is a particular traversal in a tree, a binary tree, where we will be going level by level. So we will be first going the first level, we will be printing this 4, then we move with the second level and we print 9 and 2, then we move to the third level and we are having 3 5 7. So that's level order traversal. It's kind of a breadth-first kind of a thing. So here like we will be maintaining a queue which starts with storing 4 into the queue and 4 into the queue. Now we will be just maintaining a variable, and let's initialize it to some very small value, say like integer.minval, something like that, okay. Now we will be going through each and every element in a level. So let me try to explain. So we start with having a queue. So we have a queue and we have a 4, okay. Now we can also have our max and let it be a very min value like int dot min value. Let's have like that, min, a very small value, that's all, because in the constraint like we can have any numbers in this, so we can't just say our maximum, like initialize our maximum as -1 something like. So let's make it very small value. So we start with 4, okay, and we just take the size of the queue, it's just 1, so that means we are we are at the first level, let's say that's our first level, okay. Now 4, we just take this 4 out and we just compare it with this max, okay, whether 4 is greater than this one, yes, so we will be removing this and our max is 4 for this level. For this level the maximum is 4. Now we just make sure whether its left is having any value, its right is having any value. Its left is having a value, so we add that value 9 into the queue. Its right is also having a value, so we just add 2 into the queue. So now we are done with the first level. So we just reinitialize the maximum value back to the minimum value, okay. Now we again goes through the elements inside the queue. So it's 9. First we start with the 9, okay. So we have 9, So is 9 greater than the current max value? That's for each level, like we will be resetting the max value to in min value. So at first we were at the first level, and we initialize it's as a very small value, and on the first level, like 4 is greater than that small value, so we just updated it to 4, and we are done with the first level. Now we gone to the second level. Now we are dealing with the second level, so we are just reinitializing it back to the minimum value, and we are doing with 9, and 9 is greater than this min value, so 9 is our current maximum value. Now we just check whether 9 is having left or right. 9 is having left, so we just store that value. 9 is having right, so we also store that value. So 3 and 5. Okay, now we are taking the next value in this level, so 2. So 2, and whether this 2 is greater than the current max value? No, it's not greater than the current max value, so we will not be updating our max. Rather, we will be just checking whether 2 is having any left or right. It is not having any left, so we will not be adding anything into the queue, but it is having a right 7, so we will be adding it into the queue. Okay, so now we are done with the first level, we are done with the second level. Now we are going to the third level, and we start with 3, and the first thing that we will be doing, like we will be resetting the max value back to the very small value. Okay, now we start with 3, we pop this out 3, so 3 is greater than max value, yes, so we are having 3. Perfect. Whether 3 is having any left or right? 3 is not having any left or right, so we will not be adding anything into the queue. Now we just take out this 5, and its 5 is greater than the current max. It's 3, yes, 5 is greater than 3, so we will be updating this 3 with 5. So 5 is our current maximum value. Okay, is it having any left or right? No, it's not having any left or right, so we will not be adding anything into the queue. Now we just take out the last element, that's 7, and is 7 is greater than 5? Yes, 7 is greater than 5, so we will be updating this. So we will be updating this 5 with 7. Okay, so our max is 5, and is there any left or right? No, it's not having any left or right, and we will not be adding anything into the queue. And this 7 is the maximum at this level, so we'll be storing this 497, and this is the result for this. And since the queue is empty, we will be getting out of our loop, whatever loop that we are following, and we will be just storing this in an array list, whatever the return type that the problem asks, and we'll be just returning that. So that's the idea, just level order traversal we'll do here. So let's start. So just pre-check if root is equal to null, we can just return a new array list, an empty array list. Okay, so we need an array list of integer in order to store the result. So store result, which is equal to new array list. That's perfect. Now, like we can make use of like we can write all the level order traversal logic here itself, but just let's make it into a separate method, and yeah, that will be a good practice. So what we can name this, we can have a level order traversal, and we can pass the root, our root node, and the store result, which will be storing the result, that is the maximum value, in this case 4, in this case 9, and in this level is 7, 4, so 497. And after we are done with this method, all the results will be inside this store result array list, and we can just return that store result, and that will be our answer. Now let's implement the logic for this one. Level order traversal node, and array list of integer store result. So as I told, like we will be requiring a queue here. So let's have our queue of node. Queue is equal to new linked list, and we can add the node or our root node into the queue at first. So queue dot offer of node. Now as I told, like we will be continuing until this queue becomes empty. So that's our condition. So while not queue dot is empty, we will be just holding the current level max, which is equal to a very small value, as we discussed, as we mentioned. Yeah, so current level max is equal to integer dot min val. Now let's take size is equal to queue dot size. This is to understand, like in each level, like sometimes here we are having 2, here we are having 3 elements. The next sometimes might be like 4 elements in in each level, like if we are having another left node. So we can just go through each of these elements one by one. So for int I is equal to 0, I less than size, I plus plus is the standard way how we do level order traversal in trees. So let's take out our current node, and it is queue dot poll, and we will be just comparing it with our current level max. So if current level max is less than the current node dot data, because that's how our driver code will be. Yeah, it's data. So dot data. So we will be updating current level max is equal to current node dot data. Now we just need to make sure like whether it is having left node or right node. So just two other conditions. So if the current node dot left is not equal to null, that means we are having a current node. Just put it inside the queue. Same way, if current node dot right is not equal to null, just put it back into the queue. Now after so this represents the current level, all the operations in the current level. So after exiting this loop, like we will be having the maximum of the current level. So we can just store it inside the array. Store result dot add of current level max. So that's it. So here we are making use of an extra array list. This is for storing the result, and also like we are making use of extra queue, which is made use for the level order traversal, and that can store a maximum big of n, where n is the number of nodes. So the space complexity will be big of n, and the time complexity for the level order traversal is big of n, like we are going through each and every node. So that is still big of n. So our time complexity will be big of number of nodes, and space complexity will be big of number of nodes. So yeah, so let's try running. I think there will not be any compilation error. We are good. Yeah, we are getting 1 3. Now let's try any other. Let's try this one. Okay. One 13657. So I think we are good with this one. It will be accepted. Yes. So yeah, just applying a BFS like the level order traversal, tracking each of the maximum value or the largest value in each level will do the trick. So since this is the time complexity, like we can go with the level order traversal. I think there might be some solution also with DFS using recursion, but this is also the perfect one. Yeah, thank you.